Okay, again, like I said, there are going to be 3 homework questions. I just did an example for the first question, and now I'm going to do an example for the second question. And again, I want to remind you, the third question I'm not going to put an example for, but you have, if you look at last week's discussion boards, you'll see that the examples I did for the last 2 questions for last week's homework are very similar to the one that's the third question on this homework assignment. So you'll have 3 min-max questions to do for homework. And this is the example of the second one. Now, before I start, this is really kind of important. There's a reason for the 2 questions that I'm doing. If you remember in the first one, we did a product rule. And this is very, very important. Listen carefully. I'm not doing a product rule on this one. On the first one, the square root was on the binomial. Or the power, the 1/2 power was on the binomial. On this one, notice that the binomial does not have a power, but the monomial does. Couple things about that. As long as you understand fractional exponents, it's theoretically easier, okay? It's supposed to be easier, but some of us have a little bit of trouble with the fractional exponents. You know, these 2/5 and 2/3 and 5/3 fractional exponents. So the truth is, what you want to do if the power is on the monomial, you want to distribute it in. Now remember, there's a power of 1 there, so 1 plus 2/3 is 5/3, and then 5/3. Now, it turns out that makes the derivative easier, but the algebra is also a little bit trickier. In a sense, it's not. It's supposed to be a lot easier of a question, just to be clear. But because we don't have to do a product rule, and we don't have to do as much algebra. But what I want to point out here is you do have to know how to deal with these fractional exponents, okay? And we've done them before, but just that's actually the caveat to this one. Otherwise, it would be super easy. So here's what you do. We take, first step here, we're going to take the derivative for the 1 millionth time this year. Remember, you just bring the 5/3 down and subtract the power. Now, when you bring the 2/3 down, you get 30/3 x to the negative 1/3. Now, don't reduce the fraction because I want to factor that out. Now remember, so there's the derivative. Now I need to find the critical numbers, and that's by figuring out when that derivative is equal to 0. So I'm going to factor out the third. 5 and 30 have a common factor of 5. So I'm actually factoring out a 5/3. And then the lower power here is x to the negative 1/3. Now it's been a while since we've dealt with fractional exponents and negative exponents. So just realize they behave like any other exponent. We're factoring out the lower power. Now, if I factor out a negative 1/3, subtracting a negative 1/3 is really adding a third, so I get 1. That factored out, the 3 factored out, 5 factored out, so I get plus 6. So I get 2 critical numbers. Critical number at 0 and a critical number at negative 6. Now, again, this is philosophical, not really that big a deal. Really, because of that negative exponent, it's in the denominator, so when I put the 0 in, I'm not really getting 0, I'm getting undefined, but that's okay because it still counts as a critical number. The only problem is 0's on the end of the interval here, 0 and 8, so this one still doesn't count. So all that work, and we only get negative 6. So we get our critical number. So that's the second step. Now, again, just a reminder, what we want to do now, I want to, again, just like I did in the last video, the C and D step, the finding the function value of the critical number, I need that. And then I need the D step, find the critical number, or find the function values or the Y values of the endpoints. Now, normally I make a big deal about this and we learn about fractional exponents, but being that we're doing remote learning here, just grab your calculator, okay? Just grab your calculator, just put it into the calculator. I'm okay with that. So if you put 0 in, obviously 0 times 15 is 0. And let's just do the negative 8. Negative 8, negative 8 to the 2/3 is 4. Negative 8 plus 15 is 7, so it's 28. Again, if you just want to put the negative 8, raise it to the 2/3 power in your calculator, and then multiply it. If you want to just put it in the calculator, that's fine. And I just put negative 6 in the calculator for this, and I got 29.6 717. I just made 3 decimal places because that's what we do in AP calculus, we do 3 decimal places. Obviously, we don't know what negative 6 to the 2/3 is, so you gotta kind of just put that in your calculator. Negative 6 raised to the 2/3 power, and then multiply it by 9, because that's what negative 6 plus 5 is. So now what do we say here? The 29.717 is the absolute max. Uh-oh, there it is. This is the absolute max. And the absolute min is 0. And then 0 is the absolute min. Now, you might be wondering why we worry about absolute. Don't worry about that, because there's another type of maximum called relative maximum, but that's in 3.3, and we're not going to quite get there. Okay, that would be the last section we do. So you can just write min or max instead of absolute. Don't worry about that too much. And matter of fact, if it doesn't say absolute or relative, it always means absolute. So the highest point here is 29.717, and the lowest point is going to be a 0. So this is the example for the second question on your homework. You'll have a third question on your homework, but that question is very, very similar to the ones from the previous week. Okay,